All right, so we've got our last video. We're going to solve problems with parallel lines theorems. Solving problems with parallel lines theorems. All right, so we've got a couple of theorems here to put in your notes. The parallel to the same line theorem tells us if two lines are parallel to the same line, then they are parallel to each other. So what that might look like, picture of that. That should say if. So let's say we have three lines A, B, and C. Here's A, B, and C. So let's say that line A is parallel to B. And then we're told that line C is parallel to B. So if two lines, A and C, are parallel to the same line, they're both parallel to line B, then that means they are parallel to each other. So then line A is parallel to line C. All right, our next theorem, perpendicular to the same line theorem. If two lines are perpendicular to the same line, then they are parallel to each other. So what might that look like? If, let's say we have, here is line A is perpendicular to this line, I guess I'll call it maybe C. But then we have another line that comes in and we're told that line B is also perpendicular to line C. So if you have two lines that are perpendicular to the same line, that means those lines will be parallel. So then A would be parallel to B. So let's take a look at an example where we can solve some problems with our parallel lines theorem. So we have what looks like a gate. Oh yeah, when building a gate, how does Bailey know that the vertical boards V and W are parallel? So here's the vertical board V, here is the vertical board W. So one thing that we notice is that board V we've got this right angle, so it's perpendicular to board A. Let's take a look at board W over here. Well, board W has that same right angle, so we know that board W is also perpendicular to board A. Well, what does that mean? If you have two lines, or in this case boards, that are perpendicular to the same line or board, that means that board V is parallel to board W. And that is the perpendicular to the same line theorem. All right, so part B, what should angle 1 measure to ensure that board B is parallel to board A? So we want board B to be parallel to board A, and angle 1 is being formed by board B and this board here. So I'm going to outline these so it's a little more clear. What we have, I'm going to outline the bottom of board B. I'll go ahead and outline the top of board A. And then we have, and you can extend lines if it makes it easier to see. We've got a transversal cutting through right there. All right, so angle 1, they want to know what that should be, has a relationship with this 35 degrees. Those are same side interior angles. So if same side interior angles are supplementary, then the lines are congruent. So we need the measure of angle 1 plus our 35 degree angle to equal 180. If we subtract 35 from both sides, then we need the measure of angle 1 to equal 145 degrees. Board A is parallel to board B. And that's using the converse of the same side interior postulate.